Okay, so today we're going to be going through the lecture of the CO2 fire extinguisher. So it's for the purpose of the carbon dioxide extinguisher media and what we'll use it for. There's a few extinguishers here, we'll get a chance to actually use them with my makeshift computer. But for now, I'm Danny. I've been in the fire service now for just over 3.5 years, and I've had a background in fire safety as well, so it kind of helps with when I come into the fire service with the fire safety side of things and fire extinguishers. And if you guys just want to introduce yourself, we'll start with yourself, Dan.
Yeah, so Dan, I've worked here for 3.5 years as well, from the building background really, so getting hands on with this kind of stuff's good for me, just refreshes my knowledge.
Yeah, I'm Will, been in the fire service 3.5 years. Didn't have any sort of fire service or fire safety background, but I've recently completed my fire risk assessor's qualifications. So
nice.
For fire safety basis, it's going to be quite interesting.
Yeah, cool. So we'll make a start on the lecture, and as I said, we'll get a chance to have a little play with the extinguisher as well, and just the uses of it. Okay, so the aim of this lecture is to ensure all personnel fully understand the capabilities of carbon dioxide. And then the objectives at the end of this session, RFS personnel will have a full understanding of the makeup and physical properties of carbon dioxide as used for firefighting within the aviation industry. Describe in detail the advantages and disadvantages associated with the use of carbon dioxide, and then understand the requirements for the correct operational use of carbon dioxide. Just moving on to the information now. So, the information of this presentation has been taken from the National Operational Guidance, so fires and firefighting control measure and portable fire extinguishers. And then please refer to the UK FRS website for further information and additional guidance. So the introduction. So for many years, carbon dioxide has been widely used as a fire extinguishing agent, particularly in situations involving suspected live electrical fires, or where reaching the source of the fire directly is challenging. So in that case, that can reach areas where you can't necessarily get to straight away, so it's got quite wide dispersed. So during the 1960s, through to the 1980s, halons were, which were far superior in their firefighting capability than carbon dioxide. They were introduced during this period, virtually replaced CO2 as a firefighting agent throughout the world. However, due to the ozone layer, the effect it had on the Earth's ozone layer, CO2 is now the preferred agent for electrical fires, and halon is only available for critical use. So, the physical properties of carbon dioxide. So carbon dioxide has several properties which make an acceptable firefighting agent. It does not react with most substances, so for the likes of the metal, magnesium being a notable exception. It is stored under pressure and therefore provides its pressure for discharge. On discharge, it is in a gaseous state and is therefore able to penetrate to all parts of the fire area. So it's liquid CO2 within the extinguisher, and then the pressure is provided within the extinguisher. It then disperses out as a gas in a nutshell. Okay, and then furthermore on the physical properties. So it is relatively non-toxic, and unlike halons, does not decompose in a fire and therefore produces no toxic byproducts. When liquid CO2 is released from a pressurized storage cylinder, there is this extremely rapid expansion from liquid to gas, which produces a refrigerating effect that converts part of the CO2 into snow. This snow, which is at a temperature of about -79°C, changes rapidly from solid to a gas, and as it does so, produces some limited cooling effect. I mean, it's important to know that there's not a great deal of cooling effect with CO2. Okay, so further on. So, however, it is the smothering effect, i.e. exclusion of oxygen, which is the prime factor in the extinguishing process. 1 kilogram of CO2 will produce about 0.5 of a cubic meter of free gas at normal atmospheric pressure. So a chemical symbol CO2, and then boiling point equals minus 78.5 OC, and then maximum safe exposure to agent equals 9% for 10 minutes. Is that making a lot of sense to you guys?
Yeah.
So advantages and disadvantages. So before we go into that, could we have an advantage from yourself, Dan, of what you think for CO2?
Yeah, like you say, for us here, firefighters especially, it could be like the cowling in the engine pots that we can't get to easily.
Yeah.
You know, water might not be able to get in there, it'll be bouncing back off the part, so CO2 is a good agent to use to get in there.
Yeah. And just a disadvantage, well, if you think of one.
Yeah, so obviously you mentioned that it's got a limited cooling effect. I'd say that that's one of the disadvantages. It is only
I mean,
limited.
we will go through them as well, the
Yeah.
advantages and disadvantages, but I know you guys have a general understanding anyway. So we've got a list here. So it does not, for the advantages, it does not react with most substances except for certain combustible metals such as magnesium, which we've kind of covered on one of the slides. It penetrates otherwise in inaccessible areas, so that just like Dan mentioned as well, and does not conduct electricity, which is a great one for us. It is relatively non-toxic, again great for us, and achieves some limited cooling effect. Again, it's important to know it is limited, you can't rely on it for the cooling effects. And non-damaging to most substances and does not leave a residue, recognised as being safe and a clean agent. So some disadvantages, so there's no post-discharge control, so no ability to prevent reignition. Again, that could come down to the cooling effect, or if oxygen is reintroduced, that could be by wind, etc. It could push the CO2 agent media out of the way. It's ready dispersed by wind, as mentioned. Reaction with metals, possible discharge of static electricity at nozzle, so it's important to note that. And then storage, so it's stored under relatively high pressure, strong and often heavy containers are utilised for storage purposes. So these are actually pressurised to 51 bar. So if you think your average car is like 2 bar, there's a lot of pressure, whereas like a water extinguisher is like 13 to 15. You've got a lot of pressure in CO2. And then there's excessive noise during discharge, and then impaired visibility when working in confined spaces, because it creates that cloud of CO2 as a gas, and then when used in a confined space will form a dense vapour which will impair visibility, and in high enough concentrations can become an active asphyxiant. So asphyxiant obviously taking your option away. The benefits of it could affect us. Alright. Is there anything else you need to touch on that bit, guys?
No, that's good.
Yeah.
Good information.
So this is how to operate. Hopefully the video works. So we're going to look at a video quickly, and then you'll get a chance to do it as well. So just take some mental notes of how he's operating it, and then we can go through it.
Carbon dioxide or CO2 extinguishers are signal red with a black panel. They are suitable for use on Class B fires and those involving electrical equipment. To use a CO2 extinguisher, position the discharge horn, as it will be too cold to do so when the extinguisher is being used. Pull the safety tag to break the seal. Pull out the safety pin. Hold the handle and the body of the extinguisher. Test the extinguisher to check if it works. Point the horn at the base of the flames, and whilst discharging the extinguisher, walk toward the flames in order to put them out. When the flames are out, walk back away from the fire while still discharging the extinguisher.
Alright, so that's just a quick little video, but if you'd like, what we'll do now quickly, so with the operational use again, did one of you want to have a go?
Yeah.
And then, so if you want to step up, whoever wants to come first. So taking notes on the video, and you can see if there's actually, you're aware of how to use it. Now, for the purpose of the demonstration, that is electrical fire.
Okay.
So I want you to, as with the video, just operate in the use of what you think should be done,
Okay.
and then we can just discuss it afterwards if there's any pointers needed.
So I'm going to position the horn first because it would be too cold, as the video
Yep.
explains. Take the tag off.
Yep.
And remove the safety pin. Okay. So first thing, hold up the body, not the neck because it's going to be cold.
Yeah.
Test it. Okay. And as I'm making my advancement to the fire.
Yeah. Cool.
Okay.
Yeah. Obviously, you'll have a full extinguisher for an event of fire, but for this purpose, it's enough to use. That's lovely. Okay. So you did the test. That's always important to do because you want to make sure it works before you actually approach the fire. If you're happy with that, Will, I mean, you can have a quick go if you like.
Yeah,
We've got enough
Are
time.
you happy with
So
me using?
you can use, if you want, you can use a chrome one. It's entirely up to
Okay,
you,
yeah,
or
I'll
you
use
can
one of the
use-
other ones if that
yeah.
one's.
It's no different. It's just
Yeah, that's fine.
similar approach just to see if you're actually happy
Yeah.
with using it.
As Dan's correctly said, we need to get the horn in place.
Yep.
Move or throw the safety tag on the pin.
Yep.
And then carry by the body and the trigger. I'm just going to test my video before approach. And then,
Alright.
Yeah.
Lovely. Yeah. So is that approach is on, so it's keeping you safe, and then moving away, so you're not stopping as you're at the fire as well.
Yeah.
So you're moving away, even if you think that the fire's out. That's great, guys. Brilliant. Good experience there.
Thank you.
Alright, we'll go through the rest of the slides. So, operational use. So, carbon dioxide is particularly useful when dealing with fires involving the aircraft, auxiliary power units, and fires where electrical supplies may be present and on board computer systems, which means it has the ability to penetrate areas that may otherwise not be readily accessible. So, we've seen that a couple of times now, how good it can be for not very easily accessible areas. Now, a little group activity, and there's only two of you, but just come up with one or two each maybe. Are there any other potential areas on the airfield or the airport buildings where CO2 can be used as an effective agent? So, where do you think in areas for us, particularly for the airfield and
We've got substations where
Yeah.
we often get electrical fires.
Yeah.
So you get it in, quick blast, make sure
Yeah.
it's fires out, and then
yeah, some of the server rooms or even the pits out on the airfield where we
Yeah, that's
have
a great
the,
one, yeah.
where obviously the lights are sort of, the powerful lighting's generated. Yeah, we've had in the past fires in the pits where the CO2 extinguisher is probably the best choice of
Yeah.
extinguishing agent we had because it was in an inaccessible area.
Yeah, that's great. Yeah, we've got like multiple comms rooms as well, maybe
Yeah.
different areas of the airport. We've got kitchen areas, obviously not with the facts, but like
Yeah.
any electrical equipment that can be used on it's a great bit of kit to
Yeah.
use in lots of areas. And that's great, guys. So a little summary of what we've just gone through. So RFS personnel should now have a full understanding of state the makeup and physical properties of carbon dioxide as used for firefighting within the aviation industry. Describe in detail the advantages and disadvantages associated with the use of carbon dioxide, which you guys have demonstrated, and understand the requirements for the correct operational use of carbon dioxide. Again, you guys have demonstrated that well. So just a couple of questions just to see if you've remembered little bits. So what is the maximum safe exposure to this agent?
9% for 10 minutes.
Straight away, look at that, well done. Yes, it's 9% for 10 minutes, so. And on discharge, what state is CO2 in?
Gas.
Gaseous. Well done. And question number 3, which effect is the prime factor in the extinguishing process?
Smothering.
Lovely. Any questions for me?
No, thank you. That was
No,
very
very
informative.
Very good.
Very good.
Thank you.
Thank you.
Thank you.